So hello everyone, welcome back to Algo Daily. In this particular video, we are discussing LeetCode daily problem of the day. Check if one string swap can make string equal. And the problem is uh, we have to given two string of s1 and s2 of equal length, and a string swap is an operation where you choose two indices in a string, not necessarily the different, and swap the characters at these indices, and we have to return true if the possible to make both string equal by performing at most one string swap or exactly one of the string, otherwise we have to return false. And now let's look at their problem statement, then we have to look their example test cases so that you can understand how actually we have to work. And so here we have, so first we have to given a string s1 comma s2. We have to given two strings, and these two strings are equal length, and also we have to perform at most one swap operation on exactly one of these string. Like this means we can choose two indices in one of the string. Okay, like you can choose from s1, you can choose from s2, and we have to choose one indices, uh, two indices in one of the string, and swap the characters all these indices, and then we have to check if the string becomes equal after the swap. Then we have to return s1 is equal to s2. This means this is true after swapping. And now uh, we have to look this one, at most one string swap and on exactly one. This means uh, we can swap at most one. At most once means 0 or 1 time, and after 0 and 1 time and only one string, like s1 is equal to, let's suppose, bank, and s2 is equal to can. Okay, this is also be our first example. And so this is, we can swap k and b. Okay, this k and uh, you can choose any one string. Okay, so we can swap k and b in s2, this s2, k and b. Okay, so after swap, what is what we have to get? B A N K, N K. This B A N K is equal to this uh, our original string. Like you can say original string is this one. So S1 is equal to S2. So this is our true. You can also swap this one, like B A N K. We have to swap B and K, K A N B, and this is same for S2. S1 is equal to S2. So I hope you understand what at most one string swap means. And now let's look at their constraint. So here yeah, so here we have to given one less than is equal to s1 dot length comma s2 dot length less than is equal to 100. It means strings are not too long, so we can use O of n solution. And also we have to given s1 is equal to s1 dot length is equal to s2 dot length. This means string are guaranteed to be the same, and we don't handle the case of different length cases. And s1 and s2 consist only one lowercase English letters. Like we don't have to worry about uppercase letters, digits, or special characters, so that we can check easily with their values. Okay, so now what we have to get here, we have basically the suitable example is for this problem statement. We have to check with s1 is equal to s2, and this is true. Then uh, we have to return true. Okay, and if identify the mismatch positions, then if there are exactly two mismatch, then we have to swap them and should make a string equal. And if the string is not equal, then we have to return false. And now let's look at their example first, so that you can understand how we actually work with their swapping conditions. And here first example is bank and can. Okay, and this bank mismatch position is you can say the mismatch position is this one, s1 of 0 and this s2 of 0. Okay, and this s1 of 3 and this s2 of 3. Now we have to swap any of them, like we have to swap on this s1, you have to swap this s2. So we have to swap s2, let's suppose. So after s2 swap, we have to swap with s2 of 0 and with s s2 of 3. Okay, and now what we have to get, we have to get this bank, and now this bank is equal to this s1, so we have to return true. And now again we have to check with this one, and there are no any mismatch positions. Okay, so then we have to return false. And again here we have their cal, and second one is cal, and here there is no mismatch position, and both the strings are same, already equal. Then we have to return directly true. We do not swap any elements, and then we have to return true. So now let's look at their coding implementation part so that you can understand how we swap with all elements. And now first we have their base case. This base case we have to check s1 and s2 value, and if both the strings are equal, then we have to return true. And now we have to use two pointer approach. Okay, this two pointer, first we have initialize with start and end, and then we have their while loop of if s1 of sorry, s2 of start is equal to s1 of start, and then we have to find the first mismatch. Okay, find the first mismatch, then we have to iterate with start plus plus. Then here we have while s2 of end is equal to s1 is s1 of end, then we have to find the last mismatch element. Here we have to find last mismatch element, then we have to decrease our end pointer. Okay, and then we have to swap with s2 of start and s2 of end. Okay, and then we have to swap the mismatch character. Likewise here we have to swap with their mismatch element, and after this one we have to find s1 is equal to s is equal to s2. If it is true, then we have to return true, and else we have to return false. So now what we have to do here, we have to find first, mismatch character from the left side. Okay, this one, and then we have to find the mismatch character from the right side, and after right side and left side we have to swap them. And after swapping, then if it is after swapping, we have to check with our new strings of s1 and s2, and if both are equal, then we have to return true, else we have to return false. So now the time complexity of this code is O of n, where n is the length of s1 and s2, and we scan the strings at most twice. Okay, and the space complexity of this code is O of 1, because since we have to modify s2 in place without extra storage, so that this will O of 1 solution. And now the time complexity of O of n and space complexity of O of 1. So I hope you understand the logic and the implementation part of this problem. So thank you everyone. Thank you so much.